Hi folks, this is Sumit and welcome to Acadgild's project session number 3. In last session, we discussed how to ingest the data and what are the various tables that we need to create for our further analysis. In today's session, we will look up into the actual analysis and we will wind up the session by understanding what exactly archival is and why it is important. Okay, so let's begin. So if you, I hope you all can see my screen. Okay, so this was something which we discussed in our last class. We created core Hive tables from our staging table and we encrypted the data that was passed to the core table. So this data complete, it is encrypted so that it is not in a human readable format. Now moving ahead, we will use these three tables. I'll just show you. So staging table, I mean share info, loan info and credit card info. These three tables are there which got created from their respective staging table and the data is in encrypted format. Now we will use those three tables for our further analysis. Let's see the problem statement first. So our first problem statement is find out the list of users who have at least 2 loan installments pending. That means user have taken a loan but last 2 installments have not been given. Okay, so we will assume that each installment is paid after 30 days. Okay, so tenure will be 60 days. If the installment payment have not been made within 60 days, that particular person or user will be a defaulter. So we will be writing Hive query for this and we will be finding out the result. So first and foremost, we will be again creating temporary functions to encrypt and decrypt the data. All right. So these are the functions that we will just create in our Hive. Okay, it's done. Now comes the first problem statement. Okay, before that we are setting this particular property as false, so it will not do an auto join. We need to find out the list of users, right? So very first select statement will provide us user ID. Select decrypt user ID. Actually our user ID is in encrypted format. We will be decrypting it. From which table? Loan info. Where? See, this is an inbuilt function, date diff. It is an inbuilt function present in Hive, in which if you enter 2 different dates in Unix time format, it will give you the number of days. So when we are running the query, so this from Unix timestamp, it will take the current time from your system in year, month, date format, and then we are comparing this with the last payment date that was made, the date on which the last payment was made. We are comparing this, and if the difference is greater than equal to 60, so as I said 30 days for one installment, if it is more than 60 days, then that particular user ID will get produced. Okay, so from Unix timestamp gives you the current date. Last payment date is one of the field present in our loan info table, and then we are finding the difference between the last payment date and current date. If that is greater than 60, we will be getting the ID. So let's run this. Okay, you see we have got the data. Okay, so these two are the user ID who have not paid their loan past 2 months, we can say 2 installment. Okay, similarly we have question number 2 and question number 3, for which answer is present in our solution execution doc, and it is quite self-explanatory. Complete it is Hive query, wherein we are using some of the inbuilt functions of Hive to find out the analysis. Moving ahead, we have archival. So in our first session, we discussed what exactly is the problem with smaller files. Hadoop is not built Hadoop is not built to handle multiple smaller files. Instead of that, you pass on one huge file. Hadoop will do faster analysis on that. Okay, so survey was done by the organizations in different geographic location, and then we need to find out on those particular surveys, we need to find out the user behavior, or what exactly is the company standard on the user's point of view. So those things we need to find out, I mean, for analysis. So first of all, there is a directory. Okay, I'll show you. You will have survey files directory that will consist of 3 different surveys. Okay, you can consider one survey of one location. So date is there, what are the different questions, and some of the values is there. So details are there in the project document. So these are the 3 files. What we need to do is we need to merge these 3 smaller files into one single file, pass it to Hadoop, and there we will be writing some query, some Hive query against that single file, and we will find out the analysis. Okay, friends? So let us see how to do that. So first of all, I have that particular file in home Acadgild path. So when I do ls, you see 3 different txt files are there. Now we will be merging these 3 files into one. So the command for which is cat all the files ending with the extension txt into a file survey data. So this is a simple Linux command. Now when you do ls, you have a new file called survey data, and when you do cat on survey data, you will have the data from all the 3 files. Okay, so this is something which we have done now. Now we will put this file into Hadoop. If you want, you can remove the txt files. Okay, now we will be creating Hive table and loading the data. I mean, either you can create an external table, pass the data, the merged file, that is your single file that got created, survey data file, either you can pass it to HDFS, create external Hive table and point it to HDFS, or you can load this data from your local file system as well. Okay, so let us create the Hive table. So I'll just copy from the solution doc, and we are creating a table named survey analysis. It's done. So as of now, there will be no data in this particular table because we haven't loaded it yet. Okay. Now from the local file system, where our single merged file is there, we will load that into our Hive table. You see the path which I am giving. Under survey files, we had survey data. Survey data is a single file after merging 3 different files, and this is getting loaded. Okay, so once this gets loaded, we can write our Hive query. Okay, it is done. Now you do select star, so we have the complete data with us. Now let's see the problem statement. So these are the various fields. If in case you are confused what a different field means to, so these are the different fields. So very first problem statement is how many surveys got an average rating of less than 3, where in the survey 10 distinct users gave their rating. It's not like a single user gave the rating, so at the end the survey's rating is less than 3, you need to print. No, it's not that. At least 10 distinct users should have given the ratings, and out of that average rating should be 3. So how many such surveys were there? Okay, so for this, the solution is available. So we are finding the survey ID and then average of rating. Okay, from where? So now condition is, see, if it's a simple, if it would have been problem statement only till here, how many surveys got an average rating of less than 3, then it would be quite straight and simple solution. But we have a condition wherein at least 10 distinct users should have given the rating. So for that, we are writing an inner query, inner Hive query, in which we are getting survey ID, rating, and then we are counting the user ID partition by survey ID as number of users. So this particular query will give you distinct users. Okay. Now we are giving an alias as number of users. Now we are giving a condition where number of users are greater than 10, group it by survey ID, and then average rating should be less than 3. For such particular rows, we will be getting the ID and average rating. Okay. So let's copy this and paste it. So we will wait until the MapReduce job is over. So I hope you got this particular point. This is important, guys. Just notice this. Count user ID over partition by survey ID. So this is called window analytics in Hive. Okay, this is very important, very important. Okay, so these are the complex queries which cannot be written easily. So a query is present inside a query, an inner query. From there you are finding some kind of analysis. So you just make a note of this and try to think what exactly will be output of this particular inner query, and then you write an outer query on that. Okay, so let us see if the result got executed. No, not yet. So let's wait for some time. So there is another question as well for which we have provided the solution, and we will be winding up this project session by doing some analysis on email data as well. So we will come to that once we find the solution for this. Okay, so here's the output, guys. So we have the output present for which average survey rating is less than 3. Okay, so moving ahead, the organization also has lots of emails stored in small files. The same concept we will apply. We will merge the smaller files into one, and then we will be doing further analysis. Okay, so read the XML file for the email structure and pack all the email files in HDFS. After that, you will be doing some kind of analysis. Let us see the solution for this. So there is a Python script. Okay, so this is the file we have to look for. Just a minute. There is a file called email creation table. Okay, so this is a Python script. Okay, what exactly we are doing is, there is an XML file called email schema.xml. I'll show you how exactly it looks like. Okay, so there are various fields: name, ID, type, integer, name, reporting date, type, string. Similarly, message, closed, opened. Okay, so what we are doing is, we are reading this particular file and replacing all the tabs with nothing, all the space with nothing. Okay, so the tabs and spaces are getting replaced with nothing. Okay, then loading this particular base string using this element tree in the alias named root. Now from all the we are creating a list. Okay, and inside that we are looking for the field name and type. Okay, so name and type, we are looking for that. Then we are creating, we are writing a simple statement: create table email analysis and then join structured list. In your structured list, you will have all this particular field, name, type, name type. So everything will get loaded in your structured list. Okay, and then we are using it here in our simple statement. So you might be familiar with this. This is to create a Hive table. Now what we are doing, so create table string. Now we are creating a file hive query.hql. Inside that we are writing create database bank if it does not exist, use bank. So these things, these commands will get written into this file hive query.hql. Apart from these two commands, that is create database and use bank, the third one is create table string, which is this one, and that means creating table with various field, row format, delimited fields terminated by so and so. And after that we will be running that Hive script. Okay, so let us look for that. So I have already copied that, just give me a minute. Okay, I have a file email table.creation.txt. So let's see what exactly it is. It is the same Python script. Okay, now okay, I already have a file email schema.xml. Let me see what exactly. Okay, so that particular field is there. Okay, now we will look the solution document. So first of all, we have to run that file. Guys, as of now, there are 1, 2, 3, 4, 5, 6 tables. Okay, there are 6 tables present in Hive. I am exiting the Hive shell, and then I will be running the script from here. Python, and the name is email underscore table creation.txt. So I have executed that. Let's wait for a minute or so. So basically this will a file named hive query.hql and a table will get created. Table name will be email analysis. Okay, let's wait. It is still running. Now it have executed. Now let's do ls-lrt. A file named hive query.hql is there. When you see the file hive underscore query.hql, you see these 3 statements which we embedded in which was embedded in the Python script. First was create database, if not exist, then use particular database, and then third was create table string, which is create table command. So if you look at this particular file carefully, same thing are there: create database, use, then create table. Okay, so this particular commands were there inside hive query.hql, and then it got executed. It also got executed by the command hive-f and the whatever the file name is. Okay, so now let's log into Hive shell. Hopefully the table named email analysis would have got created. Okay, I'll use the database name bank, show tables. Yep, guys, make a note, email analysis. So let me see if any data is there. It should not be there. Basically we just created a table, empty table. There is no data. Describe email analysis, and you see the fields. ID is there, reporting date, message, closed, opened, and these particular fields were taken from your schema.xml. ID, reporting date, message, close, open. Okay, so this is the working of it. Now we will be loading the data. How to load the data? So in your project solution, there is a folder called email files, under which 2 sub files are there. Okay, so you need to merge the 2 sub files. Okay, email files, cd email files. Okay, sorry. So two files are there. We will be merging it. The same command which we used earlier. So cat. Now you do ls and then email data. You run a cat on that. So you have the data combined from two different files into a single file named email file. And we will use this file as an input to our Hive table that we created. This one. Okay. So next command would be quite simple, load data. So we will be loading the data. Okay. Guys, actually this is a Hive-e. I mean, you can directly run this from terminal. Okay. If you want to do it from inside Hive shell, you have to remove this -e and all. Okay. Just load data local in path. That has to be there. Okay. So I will exit, or let me exit from Hive shell, then copy this and enter. So this is one of the way. You can also use the traditional load data local in path into table email analysis directly inside the Hive shell. Okay, so any of your choice. So once the data is loaded, we will look what exactly is the problem statement. So we need to find out which is the longest running email. For that, the solution is available. So here is the solution. Okay, multiple inner queries are there, and then we are checking opened yes, closed yes, what are the tenure it ran, and rank 1. So we need to find out that. Okay, it have done. Now let's log into Hive shell and check what is the data inside that particular email analysis table got populated or not. So you see the data is there in our Hive table, and then for the first problem statement, this is the solution we will run. It will take definitely some time because multiple inner joins are there. Okay, so it will take some time. Till then we will wait and find out the what is the result for this. Okay, so we have got the result for our problem statement, and this is it, guys. I hope you have enjoyed this session. Do practice the codes, try to understand them, and if in case you have any doubt, you can very well reach out to the support team. Okay, and thank you. Have a great day ahead. Take care.